Problem 59. My dog is joining us. Excuse me, Moshi. Oy. In 59, we have a skier who takes off at an initial velocity of 3 meters per second, down a slope 10 degrees, and his final velocity is 15 meters per second. So what we want to know ultimately is what is the distance traveled here, and then how long does it take for him to get from the top to the bottom. So first thing that I did, make a list of what I know. I have my final velocity, I have my initial velocity, and I have my acceleration. So what you can do with that actually is find out the change in y right here. You take you set it up to solve for y. So we're plugging in 15 minus 3 meters per second, all divided by 2 times a, which is our acceleration. That gives us 11 meters. So the total distance traveled in this y displacement is 11 meters with that 10-degree slope. We take that 11, we plug it in here, and we are able to find our actual distance. I'm just using the sine of 10 equals 11 over hypotenuse. You rewrite it. Hypotenuse equals 11 divided by sine of 10 gives us 63 meters. Okay? So last part of this one is finding the time. And I use the kinetic equation change in x over t equals v1 plus vf over 2. So that change in x over time, which is velocity is displacement over time, is going to equal average velocity. Basically what that's telling us. But you rewrite it, solve for time, plug in instead of 11, which is just the y factor here, we're plugging in 63, the hypotenuse, because that's the distance that we're actually traveling. And it's just 2 times 63 all over 18, and that gives us a time of 7 seconds to get from the top of the hill to the bottom of the hill.